next is the example problem based on the plane. So in the last class we derived the plane equation of a plane in a vector form as well as a Cartesian form. So vector is nothing but r dot n cap is equal to d. D is what? A distance. R is a position vector and n cap is a unit normal vector. Next, this is what the Cartesian form. Lx plus my plus nz is equal to d. Again, d is what? A distance, and L, M, N are the direction cosines. Okay. Now we'll just solve the problems based on the equation of a plane in vector and a Cartesian form. So first one is find vector equation of the plane which is at a distance of 6 divided by root 29 from origin, and it's a normal vector from the origin is 2i minus 3j plus 4k. Okay, your normal vector is given, or unit normal vector is not given. It's nothing but here you can take the distance d is 6 divided by root 29 and the normal vector is n cap, that is the n vector 2i minus 3j plus 4k. So equation of a plane, that is a vector equation of a plane, is nothing but r dot n cap is equal to d. So r you can write it as it is, but we need to find the n cap. But our n vector is given, normal vector is given, it is not a unit normal. That means you have to find n cap. N cap is nothing but n vector is divided by modulus of n vector. So n vector is what? It is a 2i minus 3j plus 4k. So magnitude is nothing but square root of the sum of a square of coefficient of ijk. Is nothing but square root of 2 square plus of minus 3 whole square plus 4 square. Hence we can write this as 2i minus 3j plus 4k divided by square root of 3 square is a 4, 2 square is a 4, 3 square is a 9, 4 square is 16. Hence we can write 2i minus 3j plus 4k is divided by 16 plus 4 is 20, 20 plus 9 is root 29. Root 29. This is what? N cap. Now you can substitute the n cap in the general form of equation of a plane. That is, so equation of a plane in a vector form, that is r dot n cap is equal to d. So you just write the r as it is. N cap is, we got it as 2i minus 3j plus 4k divided by root 29, and this is equal to 6 divided by root 29. So this is what the required equation of the plane in a vector form. Okay, hope you guys understood this. Okay, so I'll just move on to the next example. So normal vector is nothing but you need to consider that as an n vector. You have to find the n cap. So in a vector form we have a r dot n cap is equal to d. N cap is nothing but unit normal vector. But in the question they mentioned that normal vector it is. That is a n vector. N cap is nothing but n vector divided by modulus of n vector. So second one is find direction cosines of the unit vector perpendicular to the plane which is r dot 6i minus 3j minus 2k plus 1 is equal to 0 passing through the origin. Now we have to find this as a direction cosines. So for the direction cosine, we have to consider the given thing as r dot 6i minus 3j minus 2k plus 1 is equal to 0. Write it in the standard form, r dot n, which is equal to d. It's nothing but I'll just take this constant 1 that side, r dot 6i minus 3j minus 2k, which is equal to plus 1 only I'll write. I'll not write the negative 1. Why? Because the distance should be a positive. Therefore, I'll just write this one as a positive 1 only. Okay. Now, what you do is, you just find the magnitude of this one. We have to find the direction cosines of a unit vector. It is a unit vector. It is nothing but n vector is a given. You have to find the n cap. Then you can write the coefficient of ijk as the direction cosine for the vectors. So here, modulus of 6i minus 3j minus 2k is equal to square root of 6 square plus minus 3 square plus minus 2 square. This is 36 plus 9 plus 4, which is equal to 49. 49 is nothing but perfect square 7. Now what you will do is, you just divide this equation by 7. Hence we can write that as dividing both the side by 7. Dividing both the side by 7. So we'll get vector r dot 6 by 7i minus 3 by 7j minus 2 by 7k is equal to 1 by 7. Now, which is the equation of a plane in a vector form? You can write it. It is nothing but, now it is in the form vector r dot n cap is equal to d. Now it is in this form. So n cap is nothing but unit normal vector. Hence I can conclude the problem with this shows n cap is 6 by 7i, which is minus, no, then minus 3 by 7j minus 2 by 7k is unit vector perpendicular to the plane through the origin. Hence I can write the direction cosines. Direction cosines are 6 by 7 minus 3 by 7 minus 2 by 7. Hope you guys understood. Okay, there is a slight change in this. So as I said that once I take the plus 1 this side, it will be a minus 1, right? So in that, what you will do, so we can't write it directly this minus 1 as a plus 1. So you just multiply throughout equation by a minus. Okay, if you multiply the negative sign throughout the equation, then here you will get a plus 1, and it changes with a minus 6 by 7, and this will be a plus 3 by 7 and plus 2 by 7. So here I just make a change, and this denominator will not change. Anyway, the negative square will be a positive only, and there the magnitude of this one n, you will get it a 7 only. So here I just change it, this minus 6 by 7 plus 3 by 7 plus 2 by 7. Hence the direction cosines are minus 6 by 7 plus 3 by 7 and plus 2 by 7. Is it clear? So initially what I did, so they gave the problem is like a vector r dot a 6i minus 3j minus 2k plus 1 is equal to 0. So in that I just took that plus 1 as a plus 1 itself, okay, while shifting to the RHS. So that is a plus 1 only, but you need to multiply throughout the equation by a negative sign. Okay, so in that case this positive term will be a negative and these two negative will be a plus. So hence here this n cap will be minus 6 by 7 and plus 3 by 7 plus 2 by 7. Hence the direction cosines are minus 6 by 7, then 3 by 7 and 2 by 7. Clear? So last example in this is find the distance of the plane 2x minus 3y plus 4z minus 6 is equal to 0 from the origin. So you can consider the direction ratios of a normal to the plane are. So direction ratios is nothing but the coefficient of x, y, z in an equation of a plane. That is the direction ratios of a plane are 2, minus 3 and 4. Now with the help of a direction ratios we can write the direction cosine. The direction cosines are, so how we are going to write the direction cosines is nothing but a divided by square root of a square plus b square plus c square, then b divided by the same thing c divided by. So here you can take it, this is a b and a c. Hence I can write the direction cosines are 2 divided by square root of 2 square plus minus 3 square plus 4 square minus 3 divided by square root of 2 square minus 3 square plus 4 square, then 4 divided by square root of 2 square minus 3 square plus 4 square. Here 2 divided by root of 4 plus 9 plus 16 minus 3 by root of 4 plus 9 plus 16, 4 by root of 4 plus 9 plus 16. Hence we can write this as 2 by root 29. Next minus 3 by root 29, 4 by root 29. Okay. Now you got it, the direction cosine. Now you can divide the throughout equation by root 29. Here what you will get? Divide throughout the equation by root 29 is nothing but here 2 by root 29 x, then plus of minus 3 by root 29 y, and plus 4 by root 29 z, and you can take the minus 6 to that side, it will be a plus, Therefore, 6 divided by root 29. Now you can compare this equation with an equation of a plane in Cartesian form. That is, comparing with equation of a plane in Cartesian form, that is Lx plus my plus mz is equal to d. If you compare both the equation, you will get the distance. That is, the distance is d is equal to 6 by root 29. This is what the required distance for a plane, that is 6 divided by root 29. So this is what the examples based on the equation of a plane in vector form as well as Cartesian form. Okay, hope you guys understood this.